Next, data bus. It provides a medium for exchange of data and information between various avionics subsystems. Integration of avionics subsystem in military or civil aircraft and spacecraft. So the protocol of data bus have set of formal rule and convention governing the flow of information among the system. Low level protocols define the electrical and physical standard. High level protocol deal with the data formatting, including the syntax of messages and its format. So types of protocol are command response, token passing, CSMA, CA. So command response is nothing but in the centralized controller method. Token passing, decentralized control method. CSMA, CA protocol is used in the random access method. So topology used here are how the system are interconnected in a particular fashion is determined in the topology. Linear network, ring network, switch network. So in the linear network, the cable will be linear. And then all the system are connected in across the cable. In ring network, point-to-point interconnected uh, systems are used. Data flows through the next system from previous system. So in this manner, it will be interconnected. Switch network, which will be similar to your telephone network, but it will provide communication path between the terminals. Next, MIL STD1553B. This is a type of data bus. So history of the MIL STD1553B will be learned here. So it was developed at Wright-Patterson Air Force Base in 1917. It was published first version 1553A in 1975. It was introduced in service on F-15 program. It was published during the second version 1553B in 1978. So military standard 1553, which will have command response aircraft internal time division multiplex data bus, which is a military standard presently in revision B, which has become one of the basic tool being used today for integration of avionics subsystem. So this standard describes the method of communication and the electrical interface requirement for this subsystem, which is connected to the data buses. So specification of the data bus are here the data rate is 1 megabit per second. Word length is 20 bit. Message length 32 word string is maximum. Data bits per word is 16 bit. Transmission technique is half duplex. Encoding Manchester to bypass encoding is used. Protocol command response protocol is used. Voltage mode transmission mode is used here. So elements of MIL STD1553B are bus controller, remote terminal, monitoring terminal, transmission media. This is the architecture of MIL, military standard bus, data bus. So here you'll be having bus controller, remote terminal, subsystem with the embedded remote terminal, and then everything will be connected in the cables through the redundant cables. So each and everything will be monitored by bus using the bus monitor. This is the architecture of data bus, that is multi standard data bus. So coupling methods used in data bus or transformer coupling as well as direct coupling. So in the direct coupling, you'll be having isolation resistor and transformer, which will be connected to the transceiver to the data bus. But in the transformer coupled, you will be using the transformer, two types of transformer, coupling and isolation transformer, which will be connected to the data bus through the isolation resistor with the transceiver. Next, ARINC 429 data bus. So history and motivation of that data bus is single point failure in 1553B leads to certificability problem in a civil aircraft. Addition of remote terminal requires changes in BC software, which requires frequent certification. Standard adopted in the year 1977 made its appearance in the C-17 transport aircraft. Here, point-to-point protocol is used. ARINC specification 429, or it is a specification that defines a local area network for transfer of digital data between avionics system element in a civil aircraft. It is simplex data bus using one transmitter but no more than 20 receiver for each bus implementation. There are no physical addressing, but the data are sent with the proper identifier or label. ARINC 429 is viewed as a permanent as a broadcast or multicast operation. Two alternative data rates of 100 kb per second and 12 to 14 kilobit per seconds are used. There is no bus control in the data buses or found in MIL STD 1553B. It has direct coupling of transformer, transmitter and receiver terminal. This is the architecture of ARINC 429. Here you will be having only one transmitter but different receiver. That is up to 20 receiver will be used. 20 receiver is connected through a cable ARINC 429 to cable to the transmitter.